Hello, Matthews Gatos here. In this video, we'll cover section 1.3, but before we do that, I have two questions to review section 1.2. So in the first question, it says, determine the sum of the first 30 of the arithmetic series, negative 21 minus 15.5 minus 10 minus 4.5, etc. So let's identify the things that we know to help us determine what formula to use. So I know that n is equal to 30 because I want the sum of the first 30. I know that my first term is negative 21. I don't know my last term because it says dot, dot, dot. And I know that it's increasing, and it's increasing by 5.5. And I can find that by taking the second term, subtract the first term. So I'm only allowed one thing that I don't know. So since I don't know the last term, I can't use the second formula. I will use the first formula. So S sub n is equal to 30 over 2. And then I have two term ones plus n minus 1 differences. And those differences are 5.5. So S sub n is equal to 15 times. So I'll do 2 times negative 21, which is negative 42, plus 30 take away 1 is 29, and then that's multiplied by 5.5. So I have 15 times negative 42 plus, and then I'll just multiply 29 by 5.5. And I get 159.5. So S sub n is equal to 15 times negative 42 plus 159.5. That's 117.5. And then I just multiply that by 15 to get my final answer. So the sum of the first 30 terms, 1,762.5. In my next question, this is a little bit of a twist. So in this question here, we're given the sum of the first 12 terms. So S sub 12, S sub 12, so N is 12, is 186. And then it says that the 20th term is 83. So the 20th term is 83. So I'm given two pieces of information about the same sequence of numbers. I'm given information as a series and as a specific term. And then they say they want us to find the sum of the first 40 terms. So it doesn't look like we're given a lot of information. But what I want to do is I want to compare the two different formulas. Let's start with the term. So I'm told that the 20th term is 83. So I know the n is 20. I don't know what the first term is, and I don't know what the difference is. But let's just plug that in and see what we end up with. We end up with 83 equals T1 plus 20 take away 1 differences. So 83 equals T1 plus 19 differences. So can't go much further than that. If I look at this formula here, let's go over to the sum to see what we have. So we have n and we have S sub n. So really I could use either formula. But looking at what I have for my term formula, my specific arithmetic sequence formula, I'm missing a term of T1 and D. So I'm actually going to use this formula here because it also has a term 1 and a D. So I'm going to substitute in there and see what I end up with. So S sub n is 186, and that's equal to n over 2 times 2 T1s plus n minus 1 differences. Okay, so let's simplify this a little bit. So 186 is equal to 12 over 2 is 6 times 2T1 plus 11 differences. And let's substitute this in. So I have 186, or distributed in, 6 times 2, 12T1 plus 6 times 11, 66D. So what I have here is a system of equations. I have two equations and I have two unknowns. I don't know the first term and I don't know the difference. So I'm going to borrow from what we did in Math 10C, and I'm going to solve this system of equations by either using substitution or elimination. So let's look on the next page. Here's our two equations side by side. Okay, so for this one here, I have 83 equals term 1 plus 19d. So that's that formula here. And then looking at this formula here, I notice in that formula that everything is divisible by 6. So what I'm going to do, just to make it a little bit easier on myself, is divide everything by 6. So 186 divided by 6 is 31 equals 12 divided by 6, 2t1, plus 66 divided by 6, 11d. So that's how I got my second formula here. So now that I have that, I can solve this by using either substitution or elimination. I'm going to choose elimination. So I'm going to write out my first equation, and underneath it, I'm going to write my second equation, but I'm going to take this equation and multiply everything by 2. So I'm going to distribute 2 inside the brackets. So I have 83 multiplied by 2, so that's 166, equals 2 times the first term, and then 2 times 19 is 38d. Now in doing that, I hope you see why I did that, my T1s match. So elimination, I am going to subtract the equations term by term. So 31 take away 166 is negative 135 equals 2t1s take away 2t1s are gone. And then I have 11 take away 38, negative 27d. So to solve for d, I can just divide both sides by negative 27. So I'll have negative 135 divided by negative 27, and I get my common difference is 5. Well, if I know my common difference is 5, I can put that into one of my equations to figure out the first term. So I'll go to my second equation. 83 is the first term plus 19 times 5. So I have 83 equals my first term plus 95. So to get my first term, I'll just subtract 95 from both sides. And then I get that my first term is 83 take away 95, which is negative 12. So my first term is 12. Now, we've been doing this question for quite a time now, and what the question actually asked us was the sum of the first 40 terms. So we have one more step done now that we know all of the information. So to find the sum of the first 40 terms, we now know there are 40 terms in total. The first term is negative 12. The difference is 5. I don't know my last term, so I'm not going to use that formula. So I'm back to my first formula. So to answer this question, the sum of the first 40 terms is 40 over 2, 2 term 1s plus n minus 1 differences. So sum of the first 40 terms is 20, negative 24 plus 39 times 5. So the sum of the first 40 is negative 20 times, and now I can just punch this inside the brackets into my calculator. So negative 24 plus 39 times 5, and I get 171, and then multiply that by negative 20, and I get that the sum of the first 40 is negative 3,420. And that is my final answer. Okay, so 2 really good review questions of 1.2. So let's get into 1.3. 1.3 is geometric sequences. So we dealt with arithmetic sequences. Now we're going to talk about geometric sequences. We're going to determine a rule for the general term and solve problems involving geometric sequences. So what a geometric sequence is it's a finite sequence. Terms have a common ratio, not a common difference. So this is dealing with exponential growth. So the terms in the sequence grow really fast. If I start to graph this 3, 6, 12, 14, or sorry, 24, 48, it's going to not follow a linear path. It's going to follow what's called an exponential path. So it's going to get really big really fast. So here's an example of a geometric sequence. So I want to know here why it's a geometric sequence. So I start with 1 and I go to 3. So I do that by multiplying by 3. Then I know 3 times 3 is 9, so multiplying by 3 again. But you'll remember, just like the arithmetic sequences, we always go back to the first term. So in the first term, it was actually 1 times 3 times 3, which gives me my 9. Then I go to 27, so back to the first term, I'm going to multiply by 1, 2, 3 3s to get to this one. And then for 81, always back to my first term, I'm going to multiply by 1, 2, 3, 4 3s to get that answer. So I want to come up with a little bit of a better pattern here. And just like I did for arithmetic, notice I can start with my first term, and my ratio is always 3. And instead of saying I'm multiplying by 3 times 3, I can say 3 squared, 3 times 3 times 3 is 3 cubed, etc. I want to notice a pattern. I'm always multiplying by one more 3 to T1 to get the next term. But look at how many times I do that. For the second term, I multiply by 1 factor of 3. For the third term, I multiply by 2. The fourth term, I multiply by 3, and so on. So to find the 9th term, I'm going to take my first term, which is 1, and multiply by 3 to the exponent of, if I want 9, I'm going to do it to the exponent of 8. So it's always going to be 1 less. So plugging that into my calculator, I'm going to have 1 multiplied by 6,561, which is just 6,561. Let's use that pattern to form a geometric sequence in general. So for my second term, I start with my first term and I multiply it by a ratio, and I do that 1 time. Then I start with my first term and I multiply by the ratio 2 times. R times R squared. Then to figure out the fourth term, I start with my first term and I multiply by R 3 times. And similarly for T5, I start with my first term and I multiply by 4 ratios. So in general, I start with my first term and I multiply it by the ratio. Again, the number of factors of R that I multiply by is 1 less than the term number. 1 less than the term number. 1 less than the term number. So if my term number is n, 1 less than that is n minus 1. And this is the pattern that we use to come up with the equation for a general term. So in general, the term for a geometric sequence is T sub n equals T sub 1 times R to the n minus 1, where R this time is a ratio, not a difference. And it's found by dividing any term by the term before it. So let's try an example. I want to write the general term for this sequence. Now, remember from when we did arithmetic, a general term means leave n as n, substitute in the first term and change this to ratio, and then simplify. So in general, I know that my first term is 2. The number of terms, we're going to leave it as n, and the ratio is any term, for example, term 2, divided by the term before it, which is 3. I could have also done 18 divided by the term before it, which is 3. It will always be the same thing. So in general, my term is T sub n equals the first term times by the ratio to the n minus 1. So general term, leave n as n. Okay, in a geometric sequence, the second term is negative 20, the fifth term is 160. Determine the first term and the ratio. So to determine what the ratio is, I'm going to pretend that this is really my first term, second, third, and this would be my fourth term. So I want to find the ratio. So if I did that, I would have 4 terms in my sequence. The t sub n last term would be 160. My first term would be negative 20. And I want to solve for my ratio. So let's plug that in. 160 equals my first term multiplied by my ratio to the n minus 1. So 160 equals negative 20 times r cubed. So I would just divide both sides by negative 20 to get negative 8 equals r cubed. And then to solve for r, since I've raised it to the exponent of 3, I take the third root. So r equals negative 2. So that's the first part, is that our ratio is equal to negative 2. So I know my ratio is negative 2. Now, this really wasn't the first term. It was really the second term. That wasn't the fifth term. This was really the fourth term. So let's just check if our ratio is reasonable. So negative 20 times negative 2 is positive 40. Multiplied by negative 2 is negative 80. Multiplied by negative 2 is 160. So I know I've done that correctly. Now, to find the first term, since I went along here and I was multiplying by negative 2, to go backwards to the first term, I would divide by negative 2. So negative 20 divided by negative 2, positive 10. So now I know the first term and the ratio. Okay, in this example, the population of Airdrie, Alberta has an average annual growth rate of about 11%. If the population was 28,927 in 2006, estimate its population in 2016. Okay, so let's see. The first term is when I started my population, which is 28,927. Now I'm starting in 2006 and I want to know the population in 2016. So if you look at this, let's look. 2006, it was 28,927. So 2007, 8, 9, 10, 11, 12, 13, 14, 15, and 16. I want to know how many terms that is. So I can just quickly count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the reason I listed that out is because you might think 2016 take away 2006 is 10, and you might think there are 10 terms, but we started with 2006. So we have to actually add on our starting point, which means our number of years or the number of terms is 11. Okay, now it has an average growth rate of 11%. So I want to talk about the growth rate. This is my tip for you. So my tip for you in terms of the ratio is this. The ratio is 100% plus the growth rate. The ratio is always written as a decimal. So I have 100% plus my growth rate of 11%, which is 111%. But I want to write that as a decimal. So take the 11%, add it on to the 100%, which is all of the amount before, write it as a decimal, and our ratio will be 1.10. Or sorry, 1.11. Okay, so we don't know the nth, the t sub n, the last term, which is the 11th term. So let's plug it into the formula. So t sub n, where n is 11, is equal to my first term, 28,927, multiplied by my ratio to the n minus 1, so 11 minus 1. So you can put that all into your calculator exactly as it appears. So let's do that. 28,927 multiplied by 1.11 to the exponent of 11 take away 1, which is 10. So I get that my 11th term is 82,135.93086. So the question now becomes one of rounding. So if the question said round to the nearest person, then I would round to 36, 82,136. But it just asked what the population was. So this is like saying it's 82,135 and a bit. Even though that bit is quite a bit, it's 0.93, it's on its way to the 136th person, but it hasn't reached it yet. So I will round this as 82,135. That's what I would expect the population to be. So be careful with your rounding. Since it didn't specify to round to the nearest person, I'm going to round it as 82,135. Okay, in this question here, this should look very similar to something we did in 1.1, solving for x in a geometric sequence. So we have all these variables here. We want to solve for x. So my last term is negative 10x plus 26. My first term is 3x plus 1. The number of terms is 3. And then the ratio is any term divided by the term before it. So I'll go the second term divided by the first term. Now let's put this all into the equation and see what we get. So t sub n, negative 10x plus 26, must equal my first term, 3x plus 7, multiplied by my ratio, which is negative 3x plus 9 over 3x plus 7, and that will all be to the exponent of n minus 1. So looking at that and thinking about solving it kind of gives me a headache. That's a lot of variables, and adding in the exponent makes it even more difficult. So instead of doing this, better yet, let's solve it similar to how we did in 1.1. Focus on the ratio. So what is the ratio? Let's focus on that first. The ratio is any term divided by the term before it. So the ratio is the second term divided by the first, or the third term divided by the second, or the fourth term divided by the third term. Those are all the ratio, which means they're all equal to the same thing. So here's what I'm going to do instead. I'm going to focus on the fact that both of those are equal to the ratio. So the second term, which is negative 3x plus 9, divided by the first term, 3x plus 7, is equal to the third term divided by the second term, which is negative 3x plus 9. Now this should look familiar because we solved rational equations like this, and I think this is much easier than what we started with on the previous page. So let's go ahead and try this. So to solve this rational equation, to get rid of 3x plus 7, I would multiply both sides by 3x plus 7. Okay, so that's gone. On this side, to get rid of negative 3x plus 9, I will multiply both sides by negative 3x plus 9. Oops, let's try that again, negative 3x plus 9. So to both sides. So then this is gone. So what I'm left with is negative 3x plus 9 multiplied by negative 3x plus 9 equals to, on the other side, negative 10x plus 26 multiplied by 3x plus 7. Okay, so let's use the distributive property to simplify this. So I've got negative 3x times negative 3x, negative 3x times 9, 9 times negative 3x, and 9 times 9. On the other side, negative 10x times 3x, negative 30x squared, negative 10x times 7. Then I have 26 times 3x and 26 times 7. Okay, let's tidy up. So over here, combine my like terms. over here, combine my like terms as well. Okay, so I have a quadratic. So what I want for my quadratic is I want everything on one side, 0 on the other. So I will add 30x squared to both sides. I will subtract 8 from both sides. And I will subtract 182 from both sides. Okay, so now that I have that quadratic, what I have to do now is to factor and then set each factor equal to 0 and solve. So let's go ahead and focus on that. So instead of factoring this one here, I am going to, let's see, I'm going to use the quadratic formula. So using the quadratic formula, I'm going to have x equals to opposite b plus or minus the square root, b squared minus 4ac, all divided by 2a. Look at all the review in just this one question. We have rationals, and now we have quadratics vis-a-vis the quadratic formula. So let me enter in the discriminant, which is the entire thing under the radical, the radicand, into my calculator and see what I get. So this is a bit of an ugly question. Okay, so then I get the root of 19,600 all over 2 times 39, which is 78. Okay, so we need to simplify that radical further, and it works out to be a nice root. So the square root of 19,600 is 140. Okay, so this isn't as bad as I thought it was going to be. So I have 62 plus 140 over 78, or 62 take away 140 over 78. So 62 plus 140 divided by 78, and then I'll change that into a fraction, is 101 over 39, or 62 take away 140 divided by 78, which is -1. So those are the two possible ratios. Just easy like that. Just kidding, that was a pretty big question. So let's look at all of the work that we did. And we can admire it, look at it all. Oh, and I lost all my animations here. Let me just get all of those back and just look at how beautiful this question is. Wonderful. So now we know the ratio is -1. And I know that looks like a lot of work, but trust me, this method would have been much better, or is much better, than the method that was on the other page. Okay, so this is what I wanted to cover for geometric sequences. It's like exponential growth, and really it's just as easy as 1, 2, 4. So you guys can go ahead and do the practice questions, and of course I have textbook questions that follow that as well. So I hope that this video helped, and I look forward to seeing you for the next one.